Hello everyone. Today we'll solve a famous problem on LeetCode. The problem is called Two Sum. Okay. Let's read the problem statement first. Alright. So I will take the problem statement to the drawing board. So in this problem, we have been given an array of integer nums and an integer target. Okay. So we'll have to return indices of two numbers such that they add up to the target. Alright. So you may assume that each input would have exactly one solution and you may not use the same element twice. Okay, these two parts are important here. Now let's analyze the first test case first to understand the problem better. Okay, so we have been given 2, 7, 11 and 15. From these indexes, we'll have to find out two element, let's say x and y, such that x plus y becomes equal to the target. Here our target is what? 9. The given target is 9. Okay, so we'll have to find out two indexes such that the value of these indexes makes the sum 9. Now what's the solution here? Here let's mark the indexes first 0, 1, 2 and 3. Okay, so let's analyze the test cases right now. Okay. So in the first test case, we were given 2, 7, 11 and 15 and our target was 9, right? So here 2 plus 7, which makes the target 9, right? So that's why they have returned the 0th and the first index, right? So this explains this test case. Now for this test case, the target value was 6, and as you can see 4 and 2 make 6, so they have returned the first and the second index. We'll have to remember these are in zero based indexing. All right. Okay, now how can we solve this problem? So one solution that comes to our mind initially is the brute force approach. Brute force. Okay. So how can we solve it? Basically, we'll use two for loop. First for loop represent x and another inner for loop which represents y, right? Now in the second for loop, we will search if x plus y makes the target. If x plus y becomes equal to the target. So immediately when it happens, we'll just return the indexes of x and y. Okay. So this is basically, of course, this is not the optimal solution, not optimal. Why? Because as you can see, we're using true for loop, which is going through the whole array. So the complexity here becomes O of n square. Okay. So we need something better here, right? So what's the optimized approach? So we need optimized. So we need an optimized approach. Let's see the optimized approach now. So we were given 2, 7, 11 and 15 and our target was 9, right? So what we'll do is we will iterate this array from left to right, right? So we will fix one end. Okay. So let's see the equation first. X plus y is equal to t. We will fix the x. We'll fix x and then search the value of y. So as you can easily see that the target t is given. So if we fix the value of x, then we can easily find out the value of y. Y becomes t minus x, right? So let's say our current x value is 2, x is equal to 2. Now what is the value of y? Y must be 9 minus x, which is equal to 9 minus 2, that means 7. Okay, so if this value of y 7 exists in our array, then we can use that specific element to make x plus y is equal to target, right? So this will be our approach. Now how can we efficiently find this value of y? I mean, how can we check that if this value of y exists in our current array? Okay, so this can be done in many ways, but what I will use is I will use a map, right? I will use a map. So basically, map is a data structure that exists in C++. So this compares one entity with another entity. Basically, this maps one entity with another entity, right? This is basically hash map. Alright. So what we'll do is, remember, we'll have to return the indexes, not the values. So we'll first, in this hash map, we will map the indexes. So 2 appears at 0th index, 7 appears at first index, 11 appears at second index, 15 appears at third index, right? So this is our hash map, right? So let's say our current value is x, the current x value is 2, right? Now the y value, the required y value is 9 minus 2 is equal to 7. So what we will do is we will see that if we can find this value of y in this hash map. So if this is not is equal to mp dot end, that means we have find out the value of y in our hash map, right? So this is basically the solution. We'll iterate from left to right, and for each x, for each value of x, we will find out if the value of y exists in our current array. Right now, there is one edge case here. Here, this line. Okay, so you may not use the same element twice. Why this line is relevant here, right? So to understand the context behind that line, we will make a custom trait list. Let's say 2, 7, 11, 15. Sorry, 2, 4, 11, 15. But our target is now 8. Okay. So let's say we are currently as this index. So x is equal to 4. Now what is the value of y? Y becomes t minus x, which is equal to 8 minus 4 is equal to 4. Okay. So now these values are in our hash map. Okay, so from this position, if we search, no, if we find that if this current value of y exists in a whole array, we will get a positive answer, right? So we will find that yes, this value of y exists in our array, but this cannot happen, right? So what's happening here is the index of x becoming is equal to index of y. That means we are using the same element twice. Okay, so that's why this line is relevant here. We cannot use same element twice, right? So we will have to use extra condition here. The index of x cannot become equal to index of y. Okay, so if we see the code part, the problem will become more clear. Okay, so what I have done is, of course, we have been given the nums array and the target. Okay, so I have taken unordered map. All right, so you could have taken the normal map also, but the unordered map, the lookup and sometimes the complexity of find is O of 1 in average cases, right? In worst case, the complexity of find becomes O of n, but that's very rare. So in average case, the complexity of lookup and finding is O of 1. That's why I have used unordered map here. You could have used normal map. This doesn't matter. The complexity would have been n log n. We'll discuss the complexity later though. Okay, so what I've done is first I have mapped the indexes, the values with the indexes, right? Then I have iterated the array from left to right. I have assumed the current value of x and the current value as x. Then I have found out the value of y, and then I have searched that if this value of y exists in this hash map and the index of y is not is equal to the current index, right? So basically I am just checking this s case here, this extra condition here basically. Okay, so if these conditions are satisfied, then I am just returning the indexes of these values or later. Okay, so let's submit the solution first, then we'll discuss the complexity. All right, so as you can see, it gets accepted. Okay, now what's the complexity here? We are using unordered map here. So as I said, the complexity becomes O of 1 for lookup and search in average cases. Now, we are doing this for each element of the array, right? Like for each time the complexity is O of 1, so the final complexity becomes O of n, right? So the final complexity here is O of n. Okay, so which is pretty good. Okay, so that's it for today. See you next time.